Alright, so we're going to try to walk through a couple of problems. I hope this is recording right. But basically I laid out 5 problems. So here they are. First one's about solving roots. This one's pretty straightforward. Second one, using a quadratic equation. Again, pretty straightforward. Third one is kind of different, using intuition. Doing the same thing as number 1, but using intuition. Kind of no set formula or anything. And then 4 and 5 are pretty much just graphing, and I'm going to work up from lines to parabolas and just show you how the different coefficients and different things change the answer. So tripod is not really working, so I'm holding this, so this might get a little bit interesting. But okay, so number 1 had x plus 1, x minus 3 equals 0. Alright, and you want to find the roots. Okay, so when you look at something like this, when they mean find the roots, all they're saying is solve this equation, solve this so that this is correct. So, this thing you may have heard of FOIL. Foiling is basically when you just pull apart a quadratic into 2 separate multiples. And so the reason these things work, the reason why this one is pretty easy, is because you're basically saying something times something else is equal to 0, right? So we know that the only time you get 0 is if you have 0 times something, or something times 0, or 0 times 0, right? So when you look at this, you're saying, okay, for this to equal 0, one of these has to be 0, or both of them are 0. So you can just set each one equal to 0. So you say this one's equal to 0, this one's equal to 0, right? So I mean, then it just becomes very easy. X plus 1 is equal to 0, which is pretty easy to solve, right? X is equal to negative 1. And then same thing here, x minus 3 is equal to 0. X is equal to positive 3. And then if you wanted to check your work, right, if you wanted to come over here and check it, you could plug these back in. So you could say, okay, we had x plus 1 and x minus 3 is equal to 0. So if I say x is equal to negative 1, I've got negative 1 plus 1 times x minus 3 is equal to 0. Well, this turns out to be 0, right? 0 times x minus 3 is 0. That one's good. Come back, x plus 1, x minus 3. We say that x is plus 3, right? So x plus 1 and 3 minus 3. This is 0. So x plus 1 is equal to 0, right? So we're good. So that's just a simple check. You basically just take these roots that you found, sub them back in, and that tells you that you're right. But I mean, it's really as simple as this. The concept is really here, saying that because they have to be equal to 0, that we're going to go ahead and just go ahead and assume that one of them is 0, right? And then solve that equation. So that at that point it just becomes, you're looking at half of this. X plus 1 is equal to 0, x is equal to negative 1. Then you come over here, you do the other half. X minus 3 is equal to 0, x is equal to positive 3. So that's 1 in a nutshell. I'm trying to see, can I find 2? Arms cramping. Okay, so 2. 4x squared plus 8x minus 10 equals 0. Now, we're gonna do this one using the quadratic equation. I haven't looked at this. It might be possible to kind of factor this out and get to something that would look like this. Looking at it, well, I don't know if you've have done that, so I don't want to go down that road and confuse you. If you can take something like this and get it to look like something, you know, it would be for, I don't know what it is off the top of my head. But if you want me to do problems like that, let me know. I didn't see any like that, so I didn't practice any of those. But let me know if you get this and you want any practice on any of those. Just let me know sometime soon. But anyway, so we'll do this one using quadratic equation. And the thing about the quadratic equation that's great is that it's the catch-all. You can, if you're ever asked to find roots of a quadratic, and a quadratic is basically just something that has x to the power 2, so an x squared. Doesn't have to have an x, you know, doesn't have to have anything, but if it has an x squared, it's a quadratic. Anything higher than that, and you're talking about cubics and different things. So, quadratic equation is for quadratics, x to the 2. And this formula works all the time. So, kind of just to refresh it, we call this A, we call this B, and we call this C. I don't know why, they just are. So this A refers to this 4, this B refers to this 8, and this C refers to the negative 10. And basically all that's saying is you're taking the coefficients, or the real number that accompanies each variable. Okay, so the x squared is your variable, the 4 is your coefficient, that's your A. The x here is your variable, the 8 is your coefficient, that's your B. And because negative 10 is just a coefficient, then negative 10 is the C. So now the quadratic equation, you want to memorize, you want to know it. It's an excellent tool, but it can screw you if you don't remember it correctly. So different people have different ways of memorizing it. Some people would sing it, negative b plus or minus 2a. That's not mine. I don't remember. It's the wrong song. But anyway, quadratic equation, negative b plus or minus. Ooh, actually, I don't remember it. I think it's plus or minus the square root of b squared minus 4ac all over 2a. Yeah, this is right. So, this is your quadratic equation. Negative b, which is negative 8, right? Plus or minus b squared minus 4ac. All that is under this square root. 2a. Okay? So this is the equation. You really want to memorize this. You want to know this. I haven't used it in years, but I still can pull it out just because it's very, very useful. But I mean, if they ask you to find the roots of something like this, you go right here. You can try to factor this out into something like this up here, and then then you can just do the is equal to 0 is equal to 0. But this one is a little bit harder to factor, especially because it isn't already set up like that. So you come right here, and you just plug and chug. So you put in your negative 8, sorry, plus or minus square root your 8 squared minus 4 times a is 4 times c is negative 10. Remember, that's under the square root, that's important. And then all of that is over 2a, 2 times 4. Right, so you come here, oops, sorry, losing focus, sorry. Negative 8 plus or minus 8 squared minus 4 times a times c, right? 2 times a. Okay, so basically the same here, negative. See how they correspond to each other, b squared. Okay? Come this way, our negative 8 hasn't changed, plus or minus, so now our 8 squared is 64, minus, and because we've got, come back over here, we've got a negative times a negative, right, so we're just going to make that a positive. So we've got 64 plus 4 times 4, 16 times 10 is 160. Okay, all that's underneath the square root. And then 2 times 4 is 8. Alright, move one more row over. Still got this negative 8. Plus or minus. Now we've got the square root of 64 plus 160, which is what, 224? Alright, over 8. Now, Different teachers will have different methods or different opinions of how things have to cancel out. So the square root of 224 isn't anything that I know offhand. Um, it's not a round number. It's not. So, for example, the square root of 196 is 14. Square root of 225, I know, is 15. So it's somewhere between 14 and 15. Probably much closer to 15. It's probably like 14.9 or something. But it's not a round number. It's nothing that you would know offhand. So there's two ways you can look at this. A lot of teachers will just let you leave it like this, and so your answer, when you're asked to find the roots, it'll just be -8 plus, well, you'll have 2. So depending on how they want you to write it, you'll have one answer that's -8 plus square root of 224 over 8, and it's important that it's and, it's not or, -8 plus or minus, oh, sorry, I keep doing it, -8 minus square root of 224 over 8. Okay, and that's your answer. These are all your roots right here. And they look confusing, they look scary, but they're not. The only thing that's a little bit different is sometimes you can find roots in here inside a radical. And again, I don't want to confuse you if you haven't done that, but you can break these up. So 224 looks like it's divisible by 4. 224 be 112. Yeah, so 224, you could do -8. If you break out 224, we'll just do an aside over here. If this isn't something you've done before, don't worry about it. But 224, the square root, if you can break it into square root of 4 times the square root of, what would it be? It would be 224 divided by 2 be 112. 112 divided by 2 would be 56. 56. Yep. So you can break it into something like this. Okay? And I'm looking at this. 56 has square root of 8 and square root of 7 in it. So basically what you're doing when you're doing this is you're breaking it down into pieces that you know. So now we'll kind of bring this back up here. So you've got square root of 4 and square root of 56. Right? So square root of 4 is 2. We know that one. That was easy. Square root of 56 can be broken down into square root of 8 and square root of 7. Okay, now 7 we know is prime. It doesn't have anything. So we've got 2, but square root of 8 can be broken down into square root of 4 and square root of 2, right? Square root of 4, square root of 2, square root of 7. So now we know 7 is prime, we know 2 is prime, 4 square root is 2. So now we got 2 times 2, right? Now it's getting a little crowded. But we come over here, we've got 2 times 2 times root 2 times root 7. So it's just 4 root 2 root 7. Alright, and then you could just combine these two back together. So you've got 4 root 14. So if you wanted to, you could put, you could put 4 root 14 in place of this 224 over here. Or you could just leave it like that. That'll all depend on how your professor handles their answers. And if it's multiple choice, you'll probably see something like this if you haven't worked on reducing radicals. So, like I said, this could just be a whole aside that's not important. But if it is something you've gone over, then you're going to want to practice that. Just because multiple choice, a lot of times they'll steer you into wrong directions. If you do all this work with the quadratic equation and you get to this point right here and you're looking for your answer, if your teacher wants you to reduce it, you're not going to find root 224 there. They're not going to put it. So you'll think you did it wrong. You didn't do it wrong. You're just not done yet. And you want to make sure you reduce it down here. So something to keep in mind. Much in the same way you always reduce your fractions. You'll rarely ever see something like 10 over 2 as a fraction option, because 10 over 2 is just 5, right? So you want to make sure you always reduce so it doesn't confuse you. So that's 1 and 2. Like I said, real quick, 1, finding the roots, it's easy. You know that because the only time you can get a number that's equal to 0 with multiplication is if one of them is 0 or both of them is 0. So what you do is you just go ahead and set both of them equal to 0, and you solve them just like it was one equation, right? Simple. And then you can check, which is what we did over here. You plug stuff back in, and you'll get 0 for both answers. Here, you got your quadratic equation. Again, you want to know this part right here. It's so important. It'll help you do everything. If you were doing a problem like this and you had to try to factor out things, it may or may not even be doable. Like I said, I haven't done it, but you don't even have to try to do that. You could just go ahead and jump right to this step. Okay? And like I said, once you understand your A coefficient, B coefficient, C coefficient, it's a matter of just plugging them back and carrying all your math through, doing all your multiplication right, and then chugging out an answer. One thing to be cautious of, this b squared minus 4ac, it has a special name, I don't remember it right now, but it always has to be positive. This whole number, b squared minus 4ac, has to be positive because you can't have square roots of negative numbers. Those are called imaginary numbers, and you guys haven't worked on those. So this should always be positive. If you're ever trying to take the square root of a negative number, you did some math wrong in there. Okay, so that's that. So we'll do number 3. This one's really quick. I just wanted to get some practice with it. X squared minus 7x is equal to 0. Okay, so this one is pretty much like number 1. It's another simple one. So just to refresh, and actually this might be a good idea to show that you can do it 2 ways. But this is the same as what we just did on number 2. Same type of thing. If we want to find the roots, let's go back. Okay, number 2. Right, you've got a quadratic. You've got an x squared. Okay, you got an x squared here. And now you might be saying, well, there's no, here there was a 10. There was a c that didn't have an x next to it. Yeah, that's here. Okay, because you could also just rewrite this. It would be the same exact thing. X squared minus 7x, okay, plus 0 is equal to 0. It's the exact same thing. You haven't changed anything. You just added 0. Adding 0 is always okay. It doesn't do anything to anything. Okay? So these things are equivalent. So if you get confused, just remember I can always add 0. Alright? So actually, I hadn't planned to do this, but it's a perfect way to show that you can do it both ways. Alright? So we'll do it the first way, which is I call it factoring. I haven't used terminology in a while, but we're going to get it to look a lot like this one, so it's easy. You can just do it by looking at it. All right. So you factor out an x. They both have an x in it. You can pull the x out, and so you're just going to have x, right? Because this one has an x, this one has an x. We're going to take it out. So now you've just got this x left because there was an x squared. And you're just going to have this 7, alright, the minus 7, right? So from here, it's easy, right? Because we know multiplication, one of these things has to be 0. I can do it like that if it makes it simpler. One of these things has to be 0. So either this term is 0, or this term is 0, or both of them are 0 for it to equal 0, right? So do like we did last time. X is equal to 0, right? And then we solve it. That one's easy because there's nothing to solve. It's just x is equal to 0. And we do this one here. Say it's equal to 0. X minus 7 is equal to 0. Move the 7 over. X is equal to positive 7, right? Easy peasy. So these are our roots. X is equal to 0, x is equal to 7. Now, this one was pretty easy to factor out, but I just want to show you that we could still solve it using the quadratic equation. So if it's one of those things where if you only want to learn one method, learn the quadratic equation, because it does everything for you. You don't have to try to. Now, one drawback to the quadratic equation is it takes steps. So we look at how we did this one. Let's go back to 2. Look at the difference between 1 and 2. Look at how we did this one. It took us, 2 lines of work. We said, okay, equal to 0. We came down here, 1. Bang. X is equal to negative 1. X is equal to positive 3. We came down here to 2. It took us a little bit more. We had to write the equation, sub in, do some math. Did over here, did some math. Come back over here, finally have our answer. So that's the one drawback. If you're on a test and you're running out of time, you don't want to have to revert to the quadratic equation. But it'll always save you. So we'll just go here. Negative b plus or minus square root of b squared minus 4ac over 2a. Okay? We're going to do the same thing. Remember? A, B, and C. So what's our A? Right? Because and you may not see it. It's not there, but it's an invisible 1. Right? Because if it was a 2, there'd be a 2. If there was a 3, there'd be a 3. But a 1, multiplying by 1 doesn't really do anything. So oftentimes they won't put it there. Our B is our negative 7, right? And our C, we added it, right? It's a 0. So it's here, it's invisible, because adding 0, you can do it any time. So we just added it in just so we can see it. So we've got negative 7, right? That's a positive 7, plus or minus square root of b squared, which is negative 7 squared, minus 4 times a. A is 1, right? And what's c? 0. All over 2a. Oh, sorry. All over 2 times 1. Right? So we'll come down here. We've got 7 plus or minus the square root of, I guess we'll do it out, but negative 7 squared is 49. Right? And then this is a minus 0. Right? Because 4 times 1 is 4 times 0 is 0. So minus 0. And then it's all over 2. Right? We come over here. We'll just say 7 plus or minus. So now we've just got what? The square root of 49 over 2. Right? 7 plus or minus square root of 49 is 7, right? We know that one. It might be helpful to know your square roots, at least the round ones, just to make this faster. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 36, 7 times 7 49, 8 times 8 64, 9 times 9 81, 10 times 10 100, and go up to like 15 or so. You usually don't need many more than that. 11 times 11 121, 12 times 12 144, 13 times 13 169, 14 times 14 196, and 15 times 15 225. It'll just help you. It'll help you know if it's a round number. So like we talked about here with 224, I knew by looking at it, I was like, okay, it's not round, because I know 15 times 15 is 225, and 14 times 14 is 196. So it's somewhere between 14 and 15. It's not round. So if my teacher doesn't want round numbers, if they would rather me leave it there, I know I can just stop working. But if it turns out and it's 169, I know, okay, that's really just 13. But anyway, I digress. Square root of 49 is 7. Put our 7 here. Don't forget your 2. That's important. Okay, so now, basically, now you can break it up into the 2 unique answers. So you've got 7 plus 7 over 2, right? And is important again because it's both. It's not or. It's not 2 or 1. It's not 1 or 3. It's 1 and 3, right? It's both of them. Both answers are right. It's a plus and a minus. And then we've also got the 7 minus 7 over 2. Right? So we come down. So this is just 14 over 2. which, 14 divided by 2 is 7, right? And this is 7 minus 7, that's 0 over 2. 0 divided by anything is just 0, right? If you have 0 eggs and you divide them into 2 baskets, there's going to be 0 eggs in both baskets, right? Because you only had 0 to start. So 7 and 0. So you can just come down here and say x is equal to 0 and 7, right? Which is the same thing we got over here. So it just proves that you can do it both ways. One way is obviously much faster. You have to go through all of this, but you get to the same place. Okay? So that's 3. And so 4 and 5 are kind of just two practices with graphing, with parabolas. So I'll kind of show it back over here. I'll do 4. 4, these are going to be, well, I'll let us, we'll work through it. Actually, just draw a line there. I need the top half. Okay. 4, I think it said. So I divided up into 4 parts. Y is equal to x. And while I'm writing these, I want you to think about what these might look like on a graph. So we're gonna, I think we're just gonna do something like this. Put them all on one graph. Okay. And you've seen this before. It's just a coordinate plane. I'm not going to try to make a grid because it'll make it look ugly. But so y is equal to x. Be thinking about what that looks like while I'm writing these, because they're all kind of related. I broke them into basically all of the ones in 4 are going to look similar, and all the ones in 5 are going to look similar. And I want you to try to guess what they're going to look like before we actually go ahead and plot them. Alright, so y is equal to x, y is equal to 2x, y is equal to x over 2, and y is equal to x plus 3. Okay, so the easiest one to think about y is equal to x, because when we come over here, and you probably practiced these before, I forget what they're called, but I used to call them t-tables. And basically, you make a t, and you say x and y. Right? These are your x values and your y values. And if you have no idea what the thing looks like, this is where I usually start when I call this plotting points. You basically just say, if x is equal to this, what does y equal? And then you can start to plot them, and usually you can get a grasp on what it's going to look like. Alright? So, we'll just say that we'll just do easy ones. X is equal to 0, x is equal to 1, x is equal to 2, x is equal to 3. And we'll see what that looks like here. Okay? So, y is equal to x. Make sure you can tell the difference. Y is equal to x. Right? So basically, if x is 1 or x is 0, what does y equal? Y is 0. So these are easy. Basically, x and y are always going to be the same. If x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. So if you come over here, this is your x coordinate system, this is your y. Sorry, this is your x, this is your y. Gotta coordinate the camera. So yeah, so you come down here, you say, okay, x is 0. Right? This is our origin, this is 0. Okay, this is 1, 2, 3, 1, 2, 3. Anyway, so if x is 0, y is also 0, right? So there's a point there. So you come back, x is 1, y is 1, right? So what's this starting to look like? X is 2, y is 2. Sorry, this camera thing, right? X is 1, y is 1, x is 2, y is 2. X is 3, y is 3. Right? So we've got a line. And because you know these things are continuous, you can plot a few points, and you know what's happening. You can pretty much guess, because this would keep going. If I did it 4, it would be 4. If I did it -1, I'm sorry. If I did it 4, it would be 4. If I did it -5, it would be -5. They'd be the same. So it would just keep looking like this all the way down forever. And this one would keep looking like this all the way up to forever. It's what you call a linear equation. Okay? Because it's not quadratic. X is only raised to 1 power. So they're linear equations. They're going to be lines. you know, the line may be maybe sharper or steeper, or but they're going to be straight lines. Okay, so this is our y is equal to x. I wish I had different color pens or pencils or something to illustrate. Alright, but there's your y is equal to x. Alright, so now we can come over here and we're going to do y is equal to 2x. Now we know it's going to look the same. It's going to look very similar. Not the same, but it's going to look similar. And this 2 is going to modify it a little bit. And you'll see how. So we'll go kind of run out of space on this page. We'll squeeze it in here. B. Okay, and this is y is equal to 2x. Alright, so here's our x and y g chart. So we'll do the same ones. We'll just do 0, 1, 2, and 3 just because we don't want to have to mess with the negatives. The negatives will operate under the same rules. It's just a little easier to do it this way. So again, if x is equal to 0, if we sub in x, right, 2 times 0 is 0, right? So then y is equal to 0. If x is 1, plug in 1 here, y is equal to 2. Plug in 2. 2 times 2 is 4, y is equal to 4. Plug in 3, 2 times 3 is 6, y is equal to 6, right? So now we come back here, so now let's try to plot it. Let's now plot our values, alright? Take a look at them, 0, 0, 1, 2, 2, 4, and 3, 6. Okay? So, at 0, 0, we're still there, right? That one didn't change. But now if you go to x is equal to 1, right, what do we got? Y is equal to 2. So now we're going to go up 2. So 1 over for x, 2 up for y. So now we're up there. Okay? What about x is equal to 2? Well, we got 4. So we're going to go up to 4. Alright? Still looking linear, right? And what about x is equal to 3? 6. So we're going up, I didn't even mark that many, 5 and 6. You see that? So now we're coming over here, 3, all the way up to 6. So now what you can see is this is still a line. It's just a steeper line. Alright, and again, this thing will keep going all the way down, just like the last one. This is our y is equal to 2x. Alright? So basically this 2 in the front, or any number in the front, modifies the steepness of it. It'll just make it more or less steep. Okay? So you put a number that's bigger than 1, because remember we talked about where was it? Somewhere up here. There's an invisible 1. Anytime there's a variable, there's a 1 there. It's invisible. They just don't put it because you don't need it. But it's a 1. So right here we've got y is equal to 1x. Okay? When I put a number that's bigger than 1, it makes it steeper. Right? So this is our y is equal to 1x. It's kind of just going angled to the side. Y is equal to 2x is going much steeper. Right? 2x. If it had been 3x, it would be steeper. If it was 10x, it would be steeper. You know, 100x, it would be extremely steep. But yeah, any number that's bigger than 1 is going to make it more steep. Okay? Now, you should be able to guess what's going to happen then with this one. Because now we've got y is equal to x over 2. Which is just another way of saying these things are the same. Or I'll put an equal sign there so that's clear. But this is the same as saying y is equal to 1/2 x. Or also equal to saying y is equal to 0.5x. So remember what we learned. Putting a number that's bigger than 1 makes it more steep. So putting a number that's less than 1 would make it less steep. Alright? So, but we can prove it. We can show that again here. We'll come down. We'll do it just like we did the last one. So you can write whichever one is comfortable. I personally like x over 2 just because it makes doing the math in your head simpler for me. But for the purposes of this, we'll put 0.5x just so that we can see that this is a number that's smaller than 1. Oops, sorry. You can see that this number is smaller than 1. So we would expect it to be less steep than our middle ground. It should be less steep than this one, way less steep than that one, but more steep, less steep than y is equal to 1x. Alright, our X and Y table. And, you know, we can just keep doing the same ones for consistency. 0, 1, 2, and 3. Okay, so 0 times 0.5 is just going to be 0. Okay, there's a common theme. Multiply anything by 0, it's 0. Those are easy. Multiply 1 by 0.5 is going to be 0.5, right? Half of 1 is 1/2. Okay, 2 times 0.5 is going to be 1, right? 3 times 0.5 is going to be 1.5. Alright, that makes sense. We're just subbing again. We got these x's, we're just subbing them in here and figuring out what y is. We get these values. So 1 times 0.5 is just 0.5. 2 times 0.5 is 1. 3 times 0.5 is 1.5. So now we're going to come back up here. It's going to be our third line. So again, our 0 is 0, right? Because 0 times 0.5 is still 0. Now we come over to 1, and it's 0.5, right? It's not 1, 1, it's 1.5. So now it's going to get a little hairy in here. But we're at 0.5, okay? 2, what do we say? 2 is 1. So we're at like here, next to 1. Going to 3, we've got 1.5, right? 3, 1.5. Alright, so now if we draw our line to connect all of our dots, look at that. It looks just like we thought it would look. Y is equal to 0.5 x. Right? Less steep than the other ones. So you've got, this one should kind of give you context. This is your middle ground, your 1x. This is your more than 1x, you know, 2 is greater than 1, and it's more steep. This is your less than 1, and it's less steep, right? So it's kind of like, I don't know, you might think about it like, you know, if you're climbing a hill, they tell you the grade. If it's a 4% grade, a 5% grade, it means the hill is steeper, the mountain is steeper. 1%, 0.5% grade is a less steep hill. So you look at this and you say, okay, 0.5 is my grade, it's less steep. 1 is my grade, it's a little bit more steep than this one. 2 is way steep, right? 10, and like I said, you keep going up. 3, you know,